All right, everybody. I am giving this talk today about Lambda. This talk is designed not to give you a complete introduction to AWS Lambda, but to give you some sense of how we've used it here at Red Ventures, and on top of that, some things you need to watch out for and kind of all of that stuff. So I want you to imagine you're in this situation on your team at your company or on a side project or something. You're building a new application. That's pretty exciting, isn't it? There's a lot of decisions to make, a lot of things you need to figure out. The rest of your team wants to try out serverless. People have been reading blog posts about it. They're curious to give it a shot. They think that some of its benefits might be benefits for you. You run everything in AWS now, and because of that, you know that AWS Lambda is a natural option because that's their platform for this. You also know that everything in AWS comes some assembly required, and I'm here to tell you that Lambda is no different. So given that information, how do you proceed? What sorts of things do you need to build? Throughout the rest of this time, I'll outline some of this stuff, and we'll talk about different tools that you can use to do these things. Well, let's start with the basics. Imagine that you've maybe never heard of Lambda or serverless or anything like this before. Lambda is Amazon's platform for what people refer to as serverless applications or architectures. This is somewhat of a misnomer because contrary to this video, which is at some point, general manager of Lambda smashing a bunch of servers, this actually means more servers than ever before. The key tenet of serverless is that you don't need to worry about a whole host of things that you did in other infrastructure platforms, such as operating system patching, system hardening, auto-scaling, and some other stuff too. You do, however, still need to worry about things like deployment, provisioning, monitoring, and the things that don't auto-scale, because Lambda can auto-scale automatically for you up to limits, which can destroy databases and other fun things like that if you're not careful. Lambda is an evented system that's built around triggers, which is how Amazon refers to them. And the model here is that you provide some code to AWS, and written in one of these programming languages, though we'll talk about some exceptions to that. And you tell Amazon when to run this. In Amazon's UI, this looks a little bit like this. So this is some very basic code for an HTTP route. And then this is the UI for connecting it to a thing that's going to run it, connecting it to an API that's going to run it. These units of code are called Lambda functions. You see that all over their documentation. There are limits on these, which are worth knowing before going any further, which is they can run no longer than 5 minutes. Code size can be a limitation for some things, especially in the JVM, and you can only run 1,000 of them concurrently at one time per region. You can set limits on that per function. So this an important question that you need to ask yourself with that information known. Should you build with Lambda? And I'm actually not going to spend too much time addressing that question. I started making a flowchart for this at one point. It got really nasty. I made a rubric for this a little bit because the answer is it depends on 1,000 things that I can't answer for you about the sort of service that you're building, about what your constraints are. So there is an appendix someplace there's a rubric in the appendix after my final slide on here that I'll encourage you to go look at that has some of these questions about, hey, if you answer yes to this, maybe don't use Lambda or mark a point against it. If you answer yes to this, maybe do use Lambda. But the way I'll talk about this is by talking about some of the things that we've done with Lambda. And to get there, I'll say Lambda connects with a bunch of Amazon services. Unfortunately, I can't cover them all here because you would need to learn a lot of different things for that to be effective. But in general, we here at Red Ventures have done 4 types of things with Lambda. We've done stream processing work, we've built HTTP servers, we've done AWS automation, and scheduled jobs. And the only thing I'll say about scheduled jobs is that you can do them with Lambda. There's a way to give it cron expressions and run things on a schedule. But let's talk about the stream processing first. So Lambda, you can trigger Lambda, for example, when you upload files to an S3 bucket and perform some action. This is an example architecture of sorts from them, like resizing images. You can use a service from Amazon called Kinesis to produce some stream processing. This one warrants a little bit more information as you decide how you're going to build your Lambda architectures. So Kinesis, in particular, is just a big pipe of data. You can send stuff onto it, and Lambda will run for each event that you publish to Kinesis and process it in some way, however your code dictates. Lambda's actually a pretty good option for this. If you need a high throughput queue of some sorts, we've used it in a couple cases for this. Those architectures might look a little bit like this. That drop shadow turned out real weird on these slides, but where you publish perhaps a bunch of things to a central Kinesis stream, and then you have different types of actions that you need to perform on the data there. Like maybe you need to email things, maybe you're taking URLs or image data and resizing it. There's a lot you can do with it. The thing to watch out for with this is that Kinesis can only support 5 transactions per second per shard. Don't worry about what shards and streams are in this context, but what this means is that you may start to see metrics that look like this, which is Lambda iterator age. This is a measure of the delta between when basically the current time and the last time that a particular Lambda function has processed an event on the stream. So in certain cases with Kinesis in particular, and some services like it, your Lambda can spend a lot of time waiting to process events. In one case, we had a Lambda that was assigned to calculate some billing metrics that hadn't run in over 48 hours or something like that because of this issue. For HTTP servers, you connect Lambdas to a product called API Gateway. It works pretty well overall. API Gateway does a lot, though, and because of its doing a lot, it has a pretty steep learning curve as you get into it. We'll talk about some tools in a minute for making this stuff easier, but this is something to keep in mind, especially if you have existing tools for managing AWS infrastructure. Other caveats with API Gateway include API Gateways are always public to the internet, so if your security policy or whatever you're building needs to run inside an internal network, that can't happen with API Gateway right now. It may also, or may not, support some behavior you need. And the example that I can give you here is that it didn't support transmitting binary data to your Lambdas for quite a long time. It's been an option for a while now, but you couldn't do it outright. These architectures might look a little something like this, where API Gateway and Lambda can be pretty good for APIs that you need to have for things like single-page apps. Especially if they don't need to connect to data. The fun thing about this diagram is they use their DynamoDB product as an example, but it gets very, very expensive if you don't use it well. But for static content sites and simple APIs behind them, it works okay. On the AWS automation side, I'd recommend looking into step functions. Step functions are a really cool Amazon product that I don't think people use enough. They are essentially finite state machines for your collection of Lambdas. They help you coordinate both making a network of Lambdas together and coordinating to perform some task and doing things like restarts and so on and so forth, and controlling the control flow through some action or some set of actions. And the example I can give you here that we use it for is for updating immutable servers. So we have a process that will go and terminate instances that are in groups for ECS clusters, so our container clusters. That gets represented something like this in step functions. These boxes don't all represent different Lambda functions. They're just different steps in this process. So this makes it very easy for us to get around some of Lambda's limitations, like the 5-minute execution thing. They aren't appropriate for every problem, though, but especially these automation tasks, they can be great. With all of that info out of the way, let's talk about some tools that you can use to make this a little less crazy as you get into building with Lambda. You could use the AWS UI, like we showed in screenshots before, which once again looks a little bit like this. This is another Lambda. This is actually a wrapper script for something. And you could set up event triggers like this. The UI will get you pretty far, especially if you're just prototyping with Lambda. But once you get to the point where you're running something for real in Lambda, or you need to have deployment pipelines, the UI is not going to do that much for you. So I put this slide together, which has a lot of information on it that I'm going to step through a little bit, but I will encourage you to take the link at the end of the talk about my link to the slides at the end of the talk and look at some of the notes on here, because I have a ton of notes on what these different things are, pros and cons of them, and stuff along those lines. I'll highlight a few of them here now and say before I move on to the AWS SAM thing is a little confusing. Amazon refers to that as the serverless application model. It is completely separate than the thing on the row above it, which is serverless, which is an open source project that's been around a while, and that Up and Apex are similar. out of that list of things, SAM, or the serverless application model, is probably the best option for building custom pipelines. It's very AWS specific, but you can fit it into a lot of different needs, and it's fairly easy to integrate within CI. If you've used Amazon's CloudFormation product before, which is their infrastructure provisioning service, is basically a wrapper around that. It also requires that you build the most, which is one of its downfalls. I would suggest maybe pairing it with Apex, which is on that list. Apex is a deployment tool for Lambda, and it does that really, really well. SAM doesn't do the deployment directly. You kind of have to figure that out on your own. The serverless project that I mentioned before is the most portable because it supports Lambda, it supports Azure functions, Google Cloud functions, and a couple platforms that you can host yourself. And to some degree, it helps you move between them as you need to because its YAML configuration is the same, more or less, between all of those. It also has a cool plugin system, which people have used to extend it to do a ton of things that it did not do before. And finally, Up. Up comes from the developer of the Apex project that was on that list. Up is fantastic for HTTP services, and if you're building such an API with that, I would recommend looking into it as your first choice. The reason for this is that you don't typically need to change your code to run an API with Lambda and API gateway with Up. And to show this, I included this Getting Started guide for Apex. This example is in Node.js, but you write code for an HTTP service just like you would in one of the languages Lambda supports, plus more, because they have extended that as well. Tell Up to deploy it, grab a URL, and it will do some magic in the background to transparently proxy all the stuff to your code as if it were directly connected to the internet and not API gateway. It's not perfect. There are some limitations on that, again, around binary data and request size, but it's pretty good. And finally, if you use Terraform for all of your infrastructure, beware, because while you can provision Lambda functions and all of the things that you need in AWS to work with them, it gets kind of hairy, and the example I can give you with that is API gateway. So Terraform has this concept of resources. Everything in Terraform is a resource in its configuration language. S3 buckets are a resource. VMs and EC2 instances, stuff like that, they're resources. So for API gateway, you first need an API gateway REST API resource. Then you might want to set up routes on that API gateway. So you need a API gateway resource, which is what it calls them. Then you need a method to establish the method it's going to respond for. Then you need to attach your Lambda to it and point it at that. Then you need to have a response of some sort, which you don't really need for Lambda, but you do need it because API gateway. Then you need to have an integration response. So you need all of these things per route in Terraform for API gateway. We wrote a generator for this at some point that I used in a couple cases, but it's hard to be flexible because sometimes in special cases you need to customize individual ones for different reasons. So I would recommend use one of the other tools if you're going to use Lambda. But once you get your Lambdas deployed and running, you need to figure out how you're going to monitor them and how you're going to alert on them. There are lots of service-specific metrics that you'll care about, and I don't really have time to cover all of them. I'll say that API Gateway exposes metrics that you'll care about looking at, especially about request count, failures, and things along those lines. But for Lambda in particular, there's really only two that you look at for it specifically. You want to pay attention to invocation duration for functions because that's how you're billed. You're billing for Lambda functions, which is very cheap on the whole. If you compare it to Amazon's other main computing offering, which is EC2, it's much cheaper than that per invocation. But you're paid on a function of the amount of memory you assign to your Lambda function and the time that it takes to complete. You also care about invocation errors. So the model for a Lambda is it's going to run it based on how you've configured it, but if it crashes or if you report back to the thing that called it that it failed, it considers that an error. So you should ask yourself throughout your Lambda development cycle, what happens if a Lambda function crashes? Because how you're using Lambda is going to change how you answer that question. And I'll go back to this example of Kinesis a little bit, and more broadly, services that deliver data to Lambda in batch. What you don't want to have happen is something like this, where you send an alert basically for every failure of a Lambda function. You need to be more intelligent about that. So the services like Kinesis that you connect to Lambda that are queues of some sort, again, Kinesis being the prime example here, will deliver stuff in batch. And this is an example of one of ours. We had our batch size on this, I guess, set at 500. So every 500 messages that come into this stream, we're going to chunk them up and send them to that Lambda function. If one record fails in that, should the whole batch fail, or what should we do in that case? Ideally, you would build all of this stuff to be idempotent. So you send it the same data, the same result comes out, but that's not always practical with how at least we've used Lambda and Kinesis before. What tends to happen is we take the data there, we write it to a database, some SQL database typically, and if we do it again, we're going, like, the state of that data has advanced to the point where we can't do it twice. Lambda does have a feature that'll let you do what they refer to as dead letter queues, which it'll send failed data essentially to a queue in yet another Amazon service for you to perhaps process later. And my advice with that specific issue, with that specific failure, is use a dead letter queue either through that feature or manually. There's a good Cloud Guru blog post that I meant to link here or link someplace in this about using dead letter queues and the need for, in some cases, doing it twice, so aggregating failures yourself and sending them someplace and then letting Lambda do it yourself. For other details on this subject, logs you may wonder about with Lambda, it sends logs to CloudWatch logs. You can send some of your logs there, or you can forward them to a log service of your choice, which is what we have started to do with more of our things. Lambda's not one of them so much, but container logs and stuff that are in Amazon go to our on-prem elk. Well, actually not on-prem elk, it's in the cloud. But that is one thing to keep in mind as you're building with Lambda, is how you're going to get that information. If you prevent certain people from having UI access with Lambda, it can make that process a little bit more burdensome. For tracing, Amazon has a tracing service called X-Ray that does execution tracing for you. It gives you some stuff out of the box for Lambda that looks a little bit like this. It doesn't really tell you much. I made this some cool test Lambda just to get a screenshot of what it does. It did, I don't know, I think I just had it print my name or something like that. With adjustments, you can do a lot more. And again, the Cloud Guru information is very useful here. It can take a lot to get to this step, but one of the cool things about the X-Ray product, if you're living in the Amazon ecosystem, is that it gives you a lot of, it will hook into Amazon's SDKs and deliver timing information to them automatically if you want it to. But again, X-Ray is for people with UI access. So the key with Lambda that I want to get across here, and I'll kind of wrap up the main part of this talk now, is that Lambda isn't a miracle product the way that I feel people tend to talk about serverless here. Lambda can be great for some applications. We found that, especially for APIs and things that don't need to rely on much in way of SQL databases or don't need to rely on much in way of state, Lambda and API Gateway work pretty well. One of the barriers to using Lambda within your organization is that you don't just understand Lambda. If you are new to AWS, there's a big learning curve involved because you have to go learn the concepts of S3, you have to learn API Gateway, you have to learn all of the ways that you can hook into it. And that therefore Lambda is complicated, and all of these magical auto-scaling things that it does for you come with a variety of trade-offs. Your infrastructure may get more complicated as a result of using Lambda because you need to set up things for dead letter queues, and you need to worry about, if you use Terraform today, maybe you need to go fill out another tool. And incidentally, that's been one of our stumbling blocks with Lambda here, is we've historically taken the stance that cloud infrastructure is going to be in Terraform in one way or another, but it's been a challenge for numerous reasons, including Terraform being the way that it is. And that's pretty much all I got for the main portion of the talk. I do have, like I said, I have a bunch of questions here. I left these on the slides in part in case I got to them. And I went way under time this time, which is funny because I rehearsed this like 3 or 4 times and it was just about the full time. So if you're deciding to use Lambda, ask yourself if you need to run in multiple Amazon regions quickly. Lambda's pretty good at that, so that's a positive for Lambda. If you need to react to service events like S3 or Route 53, that's also a positive for Lambda because it's a pretty good option for those things. It hooks into those nicely. If you need to use an unsupported programming language, maybe don't. You can make it happen, and the tools that were on that slide that I mentioned are good at doing that for you to some degree, but it can be a burden that you don't want to have. If you're concerned about compute cost, Lambda's pretty cheap, so that makes it a good option. If your application only needs to run occasionally, maybe you have a short scheduled task that takes 30 seconds to complete or something like that, Lambda's really good for that. Bearing in mind that you need to coordinate deployments and set up pipelines for it, because that doesn't come out of the box. If your disaster recovery model involves running outside of AWS, then with tooling it can get better, but Lambda's not a great option there overall. If this is your first time using AWS, I go back and forth on that because it's either easier to use because it doesn't involve understanding. You don't have to do as much with, for example, networking in Amazon to use Lambda, but you have to learn a lot more about a lot broader set of services. If you prevent the team, finally, I guess on this list, because I removed some, if you prevent teams from having AWS UI access, maybe stay away from Lambda unless you're prepared to incur the cost of setting up log forwarding or setting up some other tracing service or integrating with existing tracing services that you have. And that's all I got, so thanks everybody.